Okay, this is chapter 4.1, solving linear inequalities in one variable. And you're going to solve and graph the inequalities in this section. I want to go over some terminology that you need. You need to be able to read these. We always read left to right. One more time, we always read, just like we read a book in English, we read these math problems left to right. And this symbol is less than. This symbol is less than or equal to. This symbol here is greater than, and this symbol, the final symbol, is greater than or equal to. So the first problem, and I'll say it, I would like you to say it in your head as well, it will help you, is going to be negative x plus 3 is less than or equal to negative 6. Your whole goal is to isolate the x value. So we're going to first subtract 3. This is just like solving equations. There are a great number of similarities. 3 and negative 3 is nothing. Negative 6 and negative 3 is negative 9. Negative x, bring down your inequality symbol, so it's now negative x is less than or equal to negative 9. This negative x plus 3 is less than or equal to negative 6 is equivalent to negative x is less than or equal to negative 9. Now we need this to be x, so we're going to divide both sides by negative 1. And here's the little tricky part. If you multiply or divide by a negative, then it reverses the sign. So a negative x or negative 1x divided by negative 1 is x. The sign is going to reverse from less than or equal to greater than or equal to. And negative 9 divided by negative 1 is positive. It's going to be positive 9. Okay, so now the next one that we are going to do is letter B, which is 3y minus 5 is less than 10. Now we're going to go ahead and solve these, and then we'll go ahead and go back and graph them so you can see that each of these can be graphed. Solving part, again, is just like solving equations for the most part. So you add 5 first, using the addition property of equality, which leaves you with 3y, negative 5 and 5 is nothing, less than, and then 10 and 5 is 15. Now this time you're going to divide by 3 using the division property of equality. Now the sign does not reverse when you divide by a positive or multiply by a positive. So it's y is less than 5. We're going to go ahead and circle those answers. Now this is what we use to graph. So we're going to go ahead and go back to the first one. We're going to draw a number line. The intervals you choose are not important as long as they're even. I should say within reason. You can't go by 9s. So I'm going to go by 3s. So 0, 3, 6, 9. I like to go one beyond, which is 12. And I also like to include a negative. So negative 3. This is a greater than or equal to, so it's a closed point above 9. I don't need to write a number because 9 is on the number line. And x is going to be greater than 9, so it's any values that are greater than 9. So 10 would work, 11 would work, 12 would work, 18 would work. So we just make sure that everything underneath that ray is going to be a solution for this inequality x is greater than or equal to 9. Let's draw a number line for this one. Now, I'm going to go ahead and go by 2s. You could go by 1s if you wanted to, but I want to show you how to go about doing this. So 0, 2, 4, 6, and then I'll put a negative 2 in. Now, because this is y is less than 5, you're going to put an open point where 5 would be. Now, there's no 5 here, so you have to tell the reader, that's 5. The values of y that would work will be less than 5, so I'm going to go to the left and check this. Use the value 0, plug it in mentally. Is 0 less than 5? Yes, it is. You've gone in the correct direction. So you have your solutions and you have your graphs. Okay, now sometimes you have variables on both sides. So here's where it's really nice if you can make sure that you end up with a positive variable coefficient. So we're going to go ahead and collect the variables to make sure we have a positive variable coefficient first. So I have a negative 4x. I can add 4x to both sides, and I have a negative 2x, so I could add 2x to both sides. Well, the best choice is to add 4x to both sides. Because what will happen then is you'll end up with negative 4x and 4x going away. You'll be left with 7. It's less than. Bring down your 1. Then you've got negative 2x and positive 4x, which is going to be plus 2x. Okay, now we're going to subtract 1 from both sides. 7 minus 1 is 6. 1 and negative 1 is nothing. We're left with 2x. Bring down your less than symbol. Again, this 6 is less than 2x is equivalent to 7 minus 4x is less than 1 minus 2x. Divide both sides by 2. Since you're dividing by a positive 2, nothing happens to the inequality symbol. 2x divided by 2 is x. 6 divided by 2 is 3. Now, many students do not like it written in this manner, so they change it to, they put the x out in front, and then that wider side has to go towards the x, so x is greater than 3. These are both the same thing, but a lot of students prefer the x is greater than 3 for graphing. Draw a number line, 0, 1, 2, 3, 4, we're going by ones. And that's going to be an open point over 3, so 3 is not a solution. It's any values that are greater. X is any values that are greater than 3, so we're going to go to the right. This 4 is greater than 3. So those are your 2 marks on that particular problem. Okay, so you have this problem, 4x minus 7 is less than or equal to 12x plus 9. I'd like you to try that. Remember to try and keep your variable coefficient, the number multiplied by a variable, positive when possible. Go ahead and try it. As soon as you've done it, turn it back on and check your work. Okay, so it was smarter to subtract 4x from both sides because then you end up with negative 7 is less than or equal to 12x minus 4x is 8x plus 9. Subtract 9 from both sides, you end up with negative 16. Negative 7 and negative 9 is negative 16 is less than or equal to 8x. Now, that negative 16 is less than or equal to 8x is equivalent to your initial inequality. You're going to divide both sides by 8. Since it's a positive 8, nothing happens to the inequality sign. Negative 16 divided by positive 8 is a negative 2. 8x divided by 8 is x. And you bring down your less than or equal to inequality. Now, a lot of students don't like it written this way, so they flip it around. So the x goes out in front. The wide part, the greater than or equal to, goes with the x, and then negative 2. These are equivalent to one another. It's a closed point over negative 2. It's all values. X are all values that are greater than or equal to negative 2, so it includes negative 2, closed point, and all values to the right. Meaning 0 is greater than negative 2, so it's part of the solution set. Everything under the ray is part of the solution set. Okay, there are 2 types of compound inequalities. The first type are and compound inequalities, and that means the variable x will be sandwiched in the middle. So sandwiches have a piece of bread on the top, piece of bread on the bottom, and then whatever's inside is in the middle. So the variable x will somehow be sandwiched in between the 2 values at the end. Or now we'll get on to or compound inequalities in just a few minutes. Let's start with and. So we're going to subtract 5, because that's our start to getting the x by itself. But if I subtract 5 from the middle term, I have to subtract it from the right term and from the left term. So negative 10 and negative 5 is negative 15, less than or equal to 3x, because 5 and negative 5 is nothing, which is less than or equal to 8 minus 5 is 3. Then we have 3x. That's still not x. I got to divide all terms by 3. Negative 15 divided by 3 is negative 5. The inequality stays less than or equal to because you're dividing by a positive 3. 3x divided by 3 is x, which is less than or equal to 1. Now we're going to go ahead and graph this. And we're going to go by ones. Negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Now, these are closed points at negative 5 and the closed point at 1. Oops. Let's put 2 right there. Now, because it is and compound inequality where the variable sandwiched in the middle, it's a line segment, but we should still check it. So we look at what's underneath the line segment, and let's pick 0, because 0 is underneath the line segment. Don't pick 1, don't pick -5, or you won't know whether you have the correct one done. So pick something under the segment. So put in 0. So -5 is less than or equal to 0, that's true. And go over and look at the other variable. 0 is less than or equal to 1. So that is correct. It should be a line segment. Now you try the next one and then check it. Shut off the recording and then check it. Okay, so again, this is an and compound inequality because it's sandwiched. It's in the middle, the variable's in the middle of these two outside values. So we're going to add 10 to all three of the values. So plus 10, plus 10, plus 10. -8 and 10 is 2. -10 and 10 is nothing, so you're left with x. And then -2 and 10 is +8. So it's 2 is less, bring down your inequality symbols. 2 is less than 10, 2 is less than x, which is less than 8. Put an open point above 2, an open point above 8, connect it with a line segment. Now let's check and see if these work. Let's use the number 4. So 2 is less than 4, that's true. 4 is underneath the segment, that's why it's a solution. And then 4 is less than 8, so that's also correct. So that is a solution. Okay, now we're going to move on to the or compound inequality. But before we do that, let's make sure that we circle our and compound inequalities here. Let's make sure we do that. There's two marks, the compound inequality and the graph. Okay, so you're just going to bring this or down. We don't need to bring it down right away. You're going to solve these just like you would a regular inequality. So we're going to add 1 to both sides. So look at one at a time. You've got 2x, -1 and 1 is nothing, is less than or equal to -6. -7 and 1 is -6. Divide both sides by 2. Do not reverse the sign because you're dividing by a positive. 2x divided by 2 is x, which is less than or equal to. -6 divided by 2 is -3. Now bring your or down. And then we go over here. 4x plus 3 is greater than or equal to 7. Subtract 3 first from both sides. 4x is greater than or equal to 4. Divide both sides by 4. Since it's a positive 4 you're dividing by, do not change the inequality symbol, so x is greater than or equal to 1. So we're going to go ahead, oops, let's put that here. We want it right over here with this or. X is greater than or equal to 1. That is your compound inequality, but you have to be careful not to forget the or. Okay, let's go ahead and look at the graph. We'll go by ones. Going one beyond the 1 and one beyond the -3. Now, ors are two rays in opposite directions. So closed points, because it's got an equal to sign. -3, 1. It'll be rays in opposite directions. Let's check it, though. So the value of x is less than or equal to -3. Well, -4 is less than or equal to -3, and that is under the ray, so that's correct. X is greater than or equal to 1, so 2 is underneath that ray. Is 2 greater than or equal to 1? Yes, it is, so this is the correct graph. Now, I'd like for you to try this next one, then turn on the recording and see how you did. Okay, it's 2x plus 8 is less than 0, or 3x plus 5 is greater than 11. Go ahead and solve that, or compound inequality, and graph it. Then check your work against mine. Okay, x is less than -4, or x is greater than 2. Open point above -4, ray to the left. Open point above 2, ray to the right. Now we're going to go on and set up your assignment. Okay, you're going to be solving linear inequalities assignment on Schoology. And you'll solve and graph, and you're going to show your work. The first two are just simple, straightforward inequalities, but again, show your work and graph it. And then the second two, 3 and 4, are compound inequalities. One is an and, one is an or. You may need to go back and look at your notes to be able to solve those. And again, do not forget to graph 3 and 4 as well. Do this on a separate piece of paper, please. We will be collecting it and checking it in class.